This is the modern atomic model. Atoms are the building blocks of the universe, and are the basic units of matter, yet were not modelled until the early 20th century. This was when Rutherford made his discovery of the nucleus. But what is the history behind the atom? How has the model of the atom changed over time? Atomism dates back over 2,500 years. Democritus was an ancient Greek philosopher that lived around 400 BC. Democritus was the first to name the smallest piece of matter, atomos, which is a Greek word meaning undivided or uncuttable. He proposed that the universe consisted of infinitely many fundamental indivisible components that came in infinitely many different varieties and shapes. Aristotle, who lived 100 years after Democritus, rejected his ideas, and, according to him, everything was composed of 4 elements: earth, fire, air, and water. As Aristotle was more influential, his ideas prevailed. In 1803, a British chemist called John Dalton revived Democritus's ideas and used evidence from experiments he conducted to prove the existence of atoms. Through an experiment involving the pressure of gases, he concluded that these gases were composed of tiny particles in constant motion. This led to his atomic theory, which consisted of 3 main ideas. 1. All substances are made of atoms and they cannot be divided into smaller particles. 2. Atoms of one element have the same properties. 3. Atoms can join together to form compounds. Dalton modelled atoms as solid spheres of matter, which was accepted until the electron was discovered. Sir Joseph John Thomson was a British physicist who was credited with the discovery of the electron. In 1897, he proved that cathode rays were composed of unknown negatively charged particles, which he calculated must have smaller mass than atoms and a very large charge-to-mass ratio. Thomson knew that atoms were neutrally charged and that they contained smaller negatively charged subatomic particles. This led to the formation of the plum pudding model. The plum pudding model consisted of negatively charged electrons sustained within a sea or area of positive charge. Ernest Rutherford was a physicist from New Zealand that conducted research into radiation and the concept of the half-life. He discovered that some elements emit positively charged particles, which were named alpha particles. Alpha particles are identical to the helium-4 nucleus, consisting of 2 protons and 2 neutrons. Ernest Rutherford, Hans Geiger and Ernest Marsden used alpha particles to study atoms in 1911, conducting the famous alpha particle scattering experiment. This experiment contains a fixed source of alpha particles, which hit a piece of thin gold foil and pass through, reaching the detectors on the other side. The entire experiment had to be conducted inside a vacuum, as alpha particles only travel a few centimeters in air. The screen was coated in zinc sulfide, which allowed Rutherford to see where the alpha particles hit. This is because zinc sulfide fluoresces when it is hit by a charged particle. The alpha source emits particles randomly in all directions, but to study how the alpha particle's path is altered, they need to ensure they only hit the foil at 90 degrees. They achieved this using a collimator. An alpha source was encased in lead with a single hole, so a controlled beam of alpha particles was fired at the foil. Gold foil was used as it is extremely malleable. Rutherford had to ensure that the foil was extremely thin, around 100 atoms, otherwise the alpha particles would have been absorbed. This animation shows the path of the alpha particles as they reach the gold nuclei. This graph shows the results of the alpha particle scattering experiment. The vast majority of particles were detected straight through the foil, which led Rutherford to believe that the atom was comprised mostly of empty space. But backscattering was occurring. The conclusion to these results were that there was a small, massive, meaning it contained lots of mass, and positively charged nucleus at the center of the atom. From these results, Rutherford formed a scattering formula that looks something like this. No, like, how do you come up with this? Anyway, Rutherford's discoveries proved that Thomson's plum pudding model was incorrect, and positive charge is concentrated in the tiny nucleus. Later research by Niels Bohr proved this correct, and this led to the planetary model of the atom.